Hello, IB Math Studies seniors. Here's another installment of some calculus. This is still section 20D continued. Thought I might do some more examples for you. We pretty much got our rules down. So this first example says find dy dx, in other words, the derivative of f of x equals 3x minus 2 squared. Now, this problem, again, we talked about this in the last lesson. This guy right here, you cannot take the derivative of this guy because I've got this expression inside of here with two different terms that's being squared. So you're not allowed to take the derivative as it stands. But we know from algebra, and algebra 2, that I can multiply this binomial out, what you kids so fondly like to call FOIL, right? So the first thing I'm going to do is I'm going to take f of x, and I'm going to FOIL him out. You're going to get 9x squared minus 12x plus 4. You see that? Now, this is going to be really familiar, I hope, from the last homework on how to find this guy's derivative. To find dy dx, and don't forget f of x is the same thing as y, that would simply equal, well, using the power rule, bring the 2 down, I'm going to get 18x minus, bring the 1 down, 1 times negative 12 is negative 12, and x to the 0 is 1, so just negative 12. And then the derivative of any constant number like 4 we said yesterday was 0. So my derivative is dy dx equals 18x minus 12. Okay, this next problem is back to what we were doing before, but we're going to do some more application here. This says find the points on f of x equals x cubed minus 2x squared plus 5, where the slope of the tangent is 4. So I'm going to start by taking my equation of my function, and I'm going to find his derivative. So f prime of x would equal 3x squared minus 4x. Everybody check my power rule technique there. And again, the derivative of 5 is 0, so it's just 3x squared minus 4x. Now, understand something. We've said in the past that the purpose of the derivative is to find the slope of this function. So if I wanted to, instead of calling this f prime of x, couldn't I call that my old friend m? Now, understand something. This equation shows a relationship between two things. It shows a relationship between the variable x and the slope of my function m. I can do one of two things with this equation. I can either plug numbers in for x and tell you what the slope is at that value of x, or I could put a number in for my slope and then solve for x. Well, in this case, aren't I being told that I want the slope of my tangent lines to equal 4? So couldn't I plug a 4 in for m and produce this lovely equation? So now to solve this guy, well, this is quadratic, so I need to make one side 0. And from here, you either have to solve this guy using our old friend Ploy-Molt 2, or we can use our old factoring skills. If I factored this guy, I would get 0 equals parentheses x minus 2 times 3x plus 2. Check my work on that and see if I'm right. If you multiply these parentheses back again, and you go back to the 3x squared minus 4x, you know that I would be right. And of course I'm right. All right, so at this point, I know that I can set each of these factors equal to 0 and solve each of these simple equations. I'm going to get x equals 2 and x equals negative 2/3. So I know the slope will equal 4 when x is 2 and when x equals negative 2/3. So there's 2 times when this cubic function will have a slope of 4, when x equals 2 and x equals negative 2/3. Now, you think I might be done, but I'm not. The problem says find the points. Now, this x is just 1/2 of the point. Don't I also have to find the y coordinate? So if I do this, I have to plug this x value into, which equation should I use to find the y value? Should I use the derivative? No, he's used to find slopes. Shouldn't I use the original equation? Isn't he used to find y values? So to find f at 2, I'm just going to put 2 in everywhere, so 2 cubed minus 2 times 2 squared plus 5 equals 8 minus 8 plus 5. So I'm going to get 5. So I know one of the points where the slope of the tangent would be 4 would be at the point 2 comma 5. Now I'm going to do it again for the second value of x, the negative 2/3. If I plug in negative 2/3, I would get negative 2/3 cubed minus 2 times negative 2/3 and then plus 5. So I'm going to get, let's see here, that's negative 8 over 27 plus 4 over 3 plus 5, which equals negative 8 over 27 plus 36 over 27 plus 45 over 27, which answer is 73 over 27. So this last point would be at negative 2/3 comma 73 over 27. So the 2 points where this graph of f of x would have a slope of 4 is at those 2 points. Okay, last example. Here's a word problem. This one says, the height of a falling math studies textbook thrown from the 200 wing on the last day of school, probably by Filippo, can be modeled using the equation h equals negative 4.9t squared plus 20t plus 15. This says find dh dt and interpret what that means. Then it says, it takes 4.5 seconds for the book to hit Mr. Kong's head. What is the velocity of the book when it smashes into his noggin? Okay, so let's handle the first part of this. So this equation, h equals negative 4.9t squared plus 20t plus 15. Again, this says to find the height of the book in meters, I should have said, when the time is in seconds, for however long the book is in the air for, you would use this equation. So if I wanted to find how high the book is after 1 second, I would put a 1 in for the t's, and it would tell me the height of the book. But this problem doesn't ask you to find the height of the book. It asks you to find what dh dt is. Now, going back to something we learned at the beginning of derivatives, dy dx. Remember that this stands for change in y over change in x. Well, if that's the case, then dh must be your change in your height, because that's what h stands for, over your change in time. That's what t stands for. So this is called this will figure out how fast your height is changing as your time changes. Now, what we call this, ladies and gentlemen, what's that called in physics? We call this change in height and change in time, where every time you have a change in distance over a change in time, we call that the velocity of the object. And all velocity is, it's kind of a fancy word for speed, but there's one difference. When I talk about speed, speed is just a number. Driving 55 miles per hour is a speed. Velocity is speed, but with a direction involved. So if I tell you I'm driving 55 miles per hour north, that's my velocity. That's no longer a speed. The speed would just be 55 miles per hour. So in this problem, if you think about this, if I were to just kind of draw this guy out, let's imagine that this book was thrown up in the air and then down again. The velocity of this book would be how fast it's traveling as it goes upward, and then how fast it's traveling as it goes downward. On this part of the graph, my velocity would be positive because the book is going upward. And whenever we describe something going up in math, we use positive numbers. After it reaches the top and it starts to go back down, this portion of the book's journey to Mr. Kong's head would be a negative number, because now the book is traveling downward, so it would have a negative number attached to its speed, or a negative sign attached to its speed, so it would have a negative velocity. Okay? Okay, so with that being said, I have to take this equation now, the h equals negative 4.9 t squared plus 20t plus 15, and I need to take his derivative to find the dh dt. So the derivative of this guy, dh dt, would equal, we're using the power rule, 2 comes down and multiplies by negative 4.9, so I get negative 9.8 t, because you subtract 1 from the exponent, plus 20 has t to the first, 1 comes down, 1 times 20 is 20, and t to the 0 becomes 1, so it's just 20, and the derivative, again, 15 is just 0. So this right here is my dh dt, and its purpose, this equation will find the velocity of the book for any given time t. All right? Well, now take a look. Let's look what this next part says. It says it takes 4.5 seconds for the book to hit Mr. Kong's head. What's the velocity of the book when it smashes into his noggin? Now, again, let's put Mr. Kong into the picture here. So let's put me into the picture. Let me see, there's an old picture of me. Let me just drag this guy in here. Ugh, man. All right, I'm looking old. So it basically is saying in this problem that it takes 4.5 seconds to go from the beginning up and then down and hit me in the head right here. Okay? So I can use this equation. If this guy right here, if dh dt is my velocity, I can plug in 4.5 in for t here, and that would find the velocity when that book hits my head. Now, does it make sense that the book's going to be hitting me on the way down, so I should have a negative number for my velocity? Well, let's check it out. If I plug in 4.5 here, and then I add 20, when I do this math, I'm going to get an answer of negative 24.1. And that should be units of meters per second, or as IB likes to say, meters per second. So that book is traveling 24 meters in 1 second. That's pretty fast. Ouch. All right, folks, that's the end of it. Talk to you later.